All right. Welcome to the show, Oscar L. Martin. Thanks so much for your time. It's a real pleasure to have you on my show for the first time. Oscar L. Martin. Let me just turn off my YouTube. Okay, Oscar, how are you doing?
Good. Thank you very much for inviting me to participate here today.
Yeah, definitely. So, Oscar, I've been following you for quite some time, and I just find your content that you've been publishing, the articles, your analysis of a lot of different sectors within the technological realm, extremely fascinating. I myself, I mean, I'm originally, I have a legal background, but then, I'm now totally into Bitcoin and do podcasts and, work for a Bitcoin company. And it has to do with a lot of first principles and, of course, with technology, with betterment for humanity. So maybe we can first, let's talk about you, your background. Maybe you can introduce yourself. Where do you come from? How did you find your path into this, let's just say, research and development? And yeah, why don't you just talk a little bit about yourself, and then we can go into, some other rabbit holes.
Yeah, well, I started as an electrical engineer, designing analog digital circuits, and later on I moved to Hewlett-Packard in Houston, and from there I learned to fly. Then I developed a passion for aviation, and I transitioned to an aerospace company. Then, to defense, and later on, I wanted to go higher, so I joined a company, and I led a couple of subsystems for the Galileo satellites, back in the almost 2 decades ago. I came back to the States, and with a previous employer. I work also in the energy industry, in thermal control, with working, designing systems. My team was designing systems for nuclear power plants or concentrated solar power, high temperature, basically. And I rejoined aviation. I work also in another company doing large screens, video screens for like the one that was once covering the NASDAQ building, was made by my team. And a little bit of these three main businesses: electronics, aerospace, energy. And I later transitioned to a more business role, restructuring companies and trying to optimize design systems, design processes, trying to implement best practice such as first principle working, 340, Lean, those kind of things, like the KISS rule, the global KISS rule, the keep it simple, stupid rule, and those things that really you find that companies and even the government, they don't know about that, and there is a lot of inefficiencies out there. And we have really big examples like the SLS rocket in space, or the solar and wind fallacy that we are falling into lately. And those kind of things. I love technology. I like anything related to the 5 foundational areas of technology: energy, materials, information, biology, and transportation. So anything regarding those 5 foundational technologies is really my passion.
Yeah, you have sort of a title or a phrase in your LinkedIn profile, transforming the present and creating the future, and I find it really fascinating because we also, within the broader Bitcoin community, a lot of us, there's a lot of Austrian economists. I don't know, maybe you've heard of Safedan Ammous, who's also written about the Bitcoin standard or the fiat standard, like the root causes of all the symptoms we have on every level you can think of, up to the criminal activities on a broader scale. But I'm not going to go there yet. It's just that sometimes when I talk to some people, or I've read some books where they analyze the technological process or the delays, the postponements, the blockages of technological innovation. Do you find it a little bit weird or strange that within the last, let's say, plus minus 100 years, we have not had a really fundamental change or transformation, as you would maybe call it, within the propulsion system, for example? It's just one example. Let's say, aviation, aerospace. Isn't that a little bit strange that we haven't had really, when it comes to transportation? I mean, we could talk about anything, any kind of technological sector. Do you find it strange? Or
no, I don't find it strange. I think that there was a huge evolution during the during the mid 20th century, with the invention of aviation and the development. So that grew up very quickly. In a matter of 3 decades, it became, the norm, and aviation is now commonplace. And it was 40 years ago. I mean, it's not new. In the 80s or in the 70s, it was normal flight from one continent to another one. And well, yeah, there was a lot of difference from jumping from a boat from transatlantic to an aircraft. So yeah, the distances have shrunk a lot due to that. Why we have not progressed? Because probably it was enough so far, and there isn't any reason to change or to reach faster. I mean, now we have the opportunity to do that. The technology is almost there with suborbital transportation. SpaceX is about to do it with the Starship system. It could perfectly move 400 to 1,000 people from one continent to another continent for an affordable price, about $5,000 per trip. I mean, still a luxury, but the first commercial flights were also luxury. If you see pictures from the 50s, 70s, from the 60s.
That's a good point. That's a good point. You're bringing it up. Yeah, because so sorry to interrupt you. It's just a very important point. Is that there's a handful of authors or technological experts or analysts who have also historically compared the technologies. Like there was I don't know, there were technological developments in the aerospace or transportation industry, like with aviation, where you could literally see that the speed had really accelerated, but then from the, I don't know from when exactly that took place, but somewhere between the 60s and 70s, all of a sudden it declined. So what happened to the Concorde, for example? I don't know, even within the military industrial complex, why wasn't there like a adaptation or further development of those innovative technologies within the civilian, for example, industry?
Yeah, well, the Concorde issue is about cost and pollution, in this case noise, more than any other thing. Also CO2 emissions and NOx emissions, all that, but noise was the biggest problem, and cost. I mean, it was really expensive to maintain that aircraft. So really the best, and there wasn't any real need. I mean, the business case was very thin. So that's why right now supersonic or even hypersonics is not the right way to move around within the atmosphere. I mean, it's like trying to go at 300 miles per hour inside water. It's not possible. So the best way is to lift the boat from the water and fly. Well, the same applies to atmosphere. I mean, if you want to go faster, the drag of the atmosphere is so high at high speed that there is no case on doing that. It's a lot easier to go outside the atmosphere, go from one point to the other, and then enter and landing. So it's the same principle. There is no point on going faster within the atmosphere. If you want to go faster, go outside the atmosphere. The atmosphere is very thin. It's just 100 kilometers, so 60 miles. So going outside is quite easy. Orbital speed is something very different. I mean, you don't need you need a lot less energy going from one point to the other with a suborbital flight than going to orbit, because going to orbit you need to go there and to get up to a lot of speed to remain in orbit. So I think that's going to be the future. The future is not going to be supersonics or hypersonics. There will be probably a very small niche market for a product, but it won't be the big revolution of airliners, for instance. So I think that the future of airliners are suborbital transportation.
Well, okay, what about, because you write and publish a lot or comment very succinctly about, from first principles, like when it comes to research and development, energy efficiency or propulsion system, even, let's just say, cars, for example, you talk about a lot hydrogen, like how far is it, like,
wow. Hydrogen has a lot of implications, even more for space right now, that Airbus is actually working hard on bringing the next generation of aircraft based on hydrogen. So yeah, I think that hydrogen, I believe that if nothing else, if there isn't a really breakthrough in energy storage, I think that hydrogen is the best way to implement electric aviation. Not using hydrogen for combustion, because it would be very inefficient, but using fuel cells and using hydrogen as a way to store electric energy. And well, I wrote an article a while ago, I think that it was 4 years ago, about that. I did a small feasibility analysis from the gravimetric point of view, from the mass. And basically, if we want to implement a typical single aisle airliners like a 737 or an Airbus 320, that size, about 200 passengers. The typical weight is about the maximum takeoff weight at takeoff is about 56 tons. Well, a battery-based aircraft will need only for the propulsion about 127 tons, only for that. So it's more than twice the weight of the whole aircraft. So it's not possible using batteries. And that was taking into account a breakthrough in batteries. Batteries capable of store about 500 watt-hours per kilogram. That doesn't exist today. I mean, even in that case, it would be impossible. So electric aviation using batteries, as of today and in the next 20 or 30 years, it won't be possible. What is the alternative? Using hydrogen. There are different ways of store hydrogen. You can compress it, or you can liquefy it and maintain at very cryogenic temperatures. Well, using compressed tanks, compressed hydrogen, it's not possible either. is very, very massive. It requires a lot of mass, not for the hydrogen, but for the tanks. So using compressed hydrogen could be possible. It's possible for road cars. Actually, here in Southern California, there are many, many around here. I see a lot of hydrogen cars, more than Teslas in 10 years ago, really. So I see a future for hydrogen cars. But for aviation, it's different. For aviation, you need to save a lot of weight. And the only way, as of today, is to liquefy hydrogen and use it, well, as the SLS, as rockets, you know, liquid hydrogen. And the problem is that we have a lot of manufacturing and knowledge about turbines. So the industry is now trying to substitute kerosene with hydrogen, still using turbines. For instance, this last week, I think Rolls-Royce announced that they have successfully tested the first hydrogen and turbine, their first hydrogen turbine, because the Russians did it in the 50s.
Exactly.
So,
yeah. What was the result? And I mean, could you go a little into detail? Like,
no, it was fine. The problem was the cost, because kerosene was a lot more affordable than hydrogen, and in the 50s, pollution was not a factor. So, and even less in Russia. So that's why hydrogen was abandoned as a means for aircraft propulsion. And well, but right now it's feasible, it's possible. In any case, turbines, hydrogen turbines, they still pollute, because in turbines you burn the fuel, but you burn also the nitrogen that is in the atmosphere. The atmosphere is 80% nitrogen. So in any air breathing system, you are breathing oxygen, 20% oxygen, well, 19% oxygen, and 80% nitrogen. So in that combustion chamber, you are burning the fuel and the nitrogen, and the byproducts of the nitrogen combustion are very toxic. So and they generate a lot of health problems. They can even produce acid rain, and well, hopefully aviation is not as important to generate acid rain. It was very common because it was part of the coal power plants. They release a lot of nitrogen oxides. Anyway, for aviation, the best way, from my point of view, is by using, well, the only way so far is by using hydrogen, liquid hydrogen, because otherwise it would be too massive, the weight would be too high for the takeoff. And fuel cells, for using hydrogen to generate electricity without toxic byproduct. The only byproduct of fuel cells is water, liquid water. So no pollution, clean electricity, and well, that way is possible. The engines probably should be superconducting engines. That is not a problem, because actually the biggest problem of superconducting is to keep cryogenic temperature. But since you are carrying liquid hydrogen, you can use that liquid hydrogen when you are feeding the fuel cells. You can go through the engines and cool the superconducting coils to reduce the weight.
I see.
To reduce a lot the weight of the engines, of the electric motors that move the fans. So that way is possible. The remaining problem is the size of hydrogen, because it's very light. Even in liquid form, it's very, very light. So it requires, the density is very small, so it requires a lot of volume. So it's good for the mass, because the weight is, in this case, is even below the current weight of the propulsion system of aircraft. mean, there will be probably about 3 more tons available for payload. But the problem will be the volume. So that's why right now you can see, if you use Google for hydrogen aircraft designs, all that, you see like the Beluga Airbus, but instead of carrying instead of a bay, is a huge hydrogen tank, or things very ugly designs. Why? Because the volume required for that is really, really high. And right now we use, well, it's very common to use the tube plus wings for the fuselage design. The airframe usually is that. It's a tube and, you know, the typical shape. That shape is very easy to manufacture because the tube is very easy. You manufacture different sections exactly the same. So it's very easy to manufacture in a line. The only different things would be the wings that are not that easy to manufacture. But if we leave that that philosophy of tube plus wing, and we leverage the current manufacturing technologies such as 3D printing and all the computing systems that we have nowadays.
This is exponentially, I mean, developing, right? I mean, especially in these. Would you say so? I mean, that is an exponential curvature in these kind of whatever it is, AI, 3D printing, or other auxiliary like technologies that can, you know, help with the, I don't know, production or
that is the cross-pollination between different industries, manufacturing industries, aviation, technology, artificial intelligence, and software in general. So those 3 areas, they can create a very good synergy for aircraft manufacturing. And if we switch from tube plus wing to shapes like the B2, the flying wing, what we call blended wing body or lifting body, that is like a large wing, you know, it's like a delta wing without the tube. So that way we can, it's like if all the aircraft was the wings, but a lot larger. So inside the wings, there is a lot more volume possible than, I mean, that shape, you have a lot more volume than in the tube plus wings. So since the weight is lower and the problem was the volume, if we use that shape, it will fit perfectly. So basically, it is possible. It's not right here. I mean, it's not. It's something that has to be developed, and it presents issues for airports because they will need to introduce hydrogen fuel systems, storage, and all that. So the technology allows for hydrogen propulsion, I mean, electric propulsion using hydrogen for storing energy. But there are many challenges ahead. But anyway, there are challenges everywhere. And if we want to reduce the carbon footprint, we need to do something.
Can I ask you something fundamental? I mean, because before we go on, I mean, first of all, I mean, I wanted to go now into the rabbit hole of nuclear technology, and because you publish also articles or commentary about modular reactors. And let me just get one topic or one thing that's like a splinter in my head always, or during, you know, all these discussions we've had also with other people, and you might also, have you ever heard of Jeff Booth, the author of The Price of Tomorrow, Why Deflation is the Key to an Abundant Future? Okay, maybe that would be an amazing conversation. I think the two of you, because he says, you know, technology is deflationary, and the technology, you know, is also the purpose to make things more, you know, comfortable for people, you know, for humanity, to lower the price. And because we never had, even our generations, we never lived on a gold standard, let alone on a Bitcoin standard, because then, you know, we would see from first principles, we would see a deflationary civilization, as to speak. We would see, you know, exponential, you know, development and innovation in every, on every level of technology, all these things that you talk about, it would lower the prices. We as society, as humanity, as people, would benefit from all these technologies. Let me just get one thing maybe out of the way first, because, and we don't have to go into conspiracy theories or whatever, but I want to talk to you about the military-industrial complex. And now, when I look at your curriculum vitae, I mean, you do work indirectly or directly for, within, or somehow, let's just say indirectly for the military-industrial complex. Maybe you can, chime in if I'm not correct on this, but could there be, I mean, I just can't fathom that in the last, let's just say, at least since the end of Second World War, or in the last 50, 60 years, I can't believe, that the military-industrial complex, who is mostly, unaccountable. I mean, there are just areas where it's like no need to know. They're unaccountable with criminal immunity, and there is no like investigation. When the trillions missing, you might remember, shortly before 9/11, who was the Rumsfeld who said, there are like $2 or $3 trillion missing. I'm just asking myself, like, where does this money go? I mean, within the compartmentalized military, industrial, technological sectors, there hasn't been like any technological development. I mean, I'm not going into speculation, but just from your depth of knowledge, experience, or interaction with other technological experts, I mean, where is all this money flow, poured into? Where's the technological innovation, or other patents that have been seized in the name of national security? I mean, is there any like bigger picture you can communicate to the?
Well, if I have to summarize in one word where the military money goes, I would choose inefficiency. But that could be also applied to any other government investment. I mean, because in energy we see the same, in the health industry we see the same. So at least here in the US. So yeah, well, where the military money goes? Well, basically to maintain the establishment, the status quo of the big primes, and that is something that started in after the 60s. The consolidation and all the fusions, the mergers between all those companies that were competitors during the 50s and 60s. That created a dangerous oligopoly in the defense industry, and thus, coupled with the very bad approach to supply chain and development in the defense industry, made the rest. I mean, because that forced the prime contractors, Boeing, Lockheed, Northrop, to work the same way. NASA is the civil version of that way of work. Very inefficient, very expensive, because the money goes to unneeded things. Basically, it all comes on how government wants things to be planned. I mean, they want to anticipate as much as possible, and they use that anticipation as a requirement. So planning become an essential part of everything, to the point that you need to plan everything before doing it, and it's impossible. And if you do that, no matter what, you will find problems afterwards. And if you want to develop something new, you cannot plan something that you haven't yet created. So if you are required to plan, then you are required not to innovate. And that is basically the big cancer of the large project. That's why after the Apollo era, there wasn't any big improvement aviation or space, the aerospace development in space. Why? Because basically the FAA, NASA, the DoD, all these governmental agencies and departments, they want to plan everything. They are not, they want to innovate, but they are not creating the framework that could foster innovation. So basically, what would be the solution? The solution would be a transition. The Space Force tried to do it, tried to get rid of all the past and try to do a new approach that was first used in software development, agile development, and that can be applied to many areas in our lives. I mean, to many development. In aviation, it can be applied. In energy, it can be applied. In anything. Why? Because basically, what you need to do is just incremental work, not planning everything at the beginning and then executing it. No, innovation is an ongoing process.
And a
It's
trial
like
and
a
error. I mean,
spiral.
we have to let, you know, innovative, intelligent people or you know, inventors, you know, engineers or, you know, technological experts, like, let's do their experiments, like trial and error. It's, you can't, you know, you said we cannot plan. Of course we can't plan, because there needs a lot of, I mean, free space, like thinking outside the box, outside the paradigm. I mean, am I going in the right direction? Or
Yes, you need to think outside the box, but I think that the problem is standardization. I mean, we want, the government and the regulations want to standardize everything. But if you create a very rigid standardization, you don't leave room for innovation. For innovation, you need to try and to get to new areas, to new inventions. Serendipity is something that only happens if you do things. If you do the same thing the same way, you won't get anything new. And that's why all the aircraft in the last 30 years are exactly the same.
Exactly. Yeah. Yeah.
No new, nothing new. Even the last engine that is being developed by GE, that has a morphing system to be able to be very efficient, very fuel efficient at one time, but very fast and very powerful when required. It's not new. The Archangel 12 from I mean the SR-71, the Blackbeard, that was a morphing engine, and that was designed in the 50s, 70 years ago.
Amazing.
So
yeah.
it's not new. It's new because that exact model is new, but the technology and the ideas are not new.
Yeah.
So
that's what I was alluding to. Yeah.
Who's innovating right now? I think that the innovation is coming from startups, that they are not very organized themselves, and that messy framework foster innovation. So my approach for optimizing this kind of innovation product development frameworks is first to not designing with the safety factors and all that at the beginning, but doing a straightforward design without safety factors, and then add the safety factor at the end. Why? Because right now we have different teams in different areas. When you are designing an aircraft, you have propulsion, you have aerodynamics, you have avionics, you have controls, many different teams. But if you do the mass budget, and then the propulsion team say, no, it's gonna be 6 tons for the engines, and then they say, no, I'm going to apply a safety factor of 10%, 20%. Usually it's 20%. Then you end up telling that your engines is going to be 7,200 kilograms, means more than 7 tons. Then you will need more lift capability, more the structures of the wings, the structure of the aircraft has to be thicker to withstand more weight. And if you need more weight, you need more propulsion. So you end up with a deadly spiral of very, very bad things. So the best thing is to apply the nominal need and then afterwards adding the safety factor. You said different times, first design from first principle. That is really, it's not new, actually. Elon Musk has made it very, very popular because they've been very, very, he's been pushing a lot on using this. And it's a great idea. I mean, this first principle design is just take whatever thing that is already done and break it down to its atomic parts or atomic functions, and then build what you want to build from those atomic functions. Well, that's the top level idea. Then you can apply, for instance, a methodology, a heuristic called TRIS-40 to find a better solution. I mean, it's a very good tool. But well, that is a way to innovate. But anyway, I think that the most powerful tool for getting something done very quickly and very efficiently is two things. First, the KISS rule, the keep it simple, stupid. The best part is no part. The best process is no process. That's clear. If you can remove things, remove it. You can add it later, but if you can remove it, remove it. That applies to product, that applies to companies, that applies to organizations, that applies to the government too. So everywhere, keep it simple with fewer parts, with fewer elements. You have fewer interfaces. With fewer interfaces, you have fewer risk of miscommunication, of failures, human error. So it's going to be an exponential benefit. And the other key thing is the fail rule, the 3 fails: fail fast, fail early, and fail inexpensive. The fail fast is do very short design cycles. You know, in software it's very easy. You change the code, and usually it's very easy to execute and to debug that routine if it's doing things right. I mean, it doesn't take that long. Probably even very, very large projects can be tested in a matter of minutes, if not hours. But the same, well, not hours, but probably in a week you can do a test cycle. If it's not a week, it's 2 weeks, and that way you can improve a lot your system. That is the fail fast. Fail early. Fail early means start testing as soon as possible. That goes completely against the planning framework. So that means that, hey, do a step, because that step is going to teach you things that planning won't. I mean, planning is actually a waste because it's not productive. It helps. It helps when you do repetitive things like buildings or houses in a.
Yeah.
It helps.
Yeah, but it's just too many parameters. Probably just not foreseeable or it cannot be calculated. Maybe, right? I mean, you have to.
Yeah, it cannot be anticipated.
Right. Right.
So that creates an overwork on top of the real work, which is thinking about the problem, solving problems, creating efficient systems. So that is the second, fail fast, start as soon as possible testing. And the third, I think that doesn't need any explanation, fail inexpensive, do inexpensive tests. I mean, try to design your tests that they are non-destructive tests. So that is basically the KEYS rule, and the fail fast, failing expensive are the two key factors. Others, additional things, I always tell my people, hey, focus on interfaces, because innovation usually happens at the interfaces, and so the errors.
Yeah.
So be very careful with interfaces. And that's why systems engineering is very important, not only at product level, but at company level.
Yeah.
When you define our organization and you create the processes, the business processes, the interfaces between that process and other processes are usually miscommunication, generates a lot of meetings that are inefficient because usually are a waste of time most of the time. So that's why interfaces is a key part in any system. System, from a very simple product to a very complex organization such a government. So basically that's the idea. And if you do all that, you will find that it's more profitable, more efficient to work smarter than to work harder.
Yeah.
And that's really important for anything that I've done so far.
Yeah.
I've been trying to innovate, not only in the things that you are doing, but in the process that you apply for doing that thing.
Say, Oscar, I mean, we talked about, or I mentioned, the compartmentalization and the patent system just is a keyword, but do you see like other root cause, or asked differently, like what should be done to facilitate and accelerate and foster and accelerate the development, the innovation, or the conversion, translation from within the military industrial complex to the civilian sector? I mean, is there anything from first principles that if you just zoom out, like what could be, because we talk about Bitcoin, we talk about money, we always say fix the money, fix the world. Like, is there anything you've been maybe talking about or thinking about, maybe with others? What needs to be done, like from the first principle, from the roots upwards?
I think that the world cannot learn a lot from the defense industry or the government industry. I think that is the opposite. I think that blockchain could be used in many areas of the government. Are
you familiar with Bitcoin, Oscar? I mean, do you know what? Yeah. Okay.
Yeah, blockchain could be applied to the voting system to avoid all the recounts and all these things.
Yeah, okay, but blockchain itself is a very primitive tool, but
yeah, it's a concept.
It's very, it delivers you consistency and verification and what we have in Bitcoin, like it's just a very primitive, very slow, very inefficient tool, but
yeah, it's inefficient.
Like I'm talking about like the monetary structure, like once we we don't have this fiat structure anymore, the central banking governmental structures, the centralization, once we have decentralized the money, where do you see ourselves, where do you see technology, where do you see humanity? That should be actually the final question, but
no, I think that money is like energy. I mean, and it follows the same movement, the same flows, more or less. So banks is like manufacturing plants, and consumers consume energy, but they also pay money. So the flow is the same, and decentralization is something that it's a good idea, but I see a big problem. No one wants to give up control. So that's why microgrids in the energy industry or decentralized banking system is something that is very difficult to achieve. Why? Because it removes control, and that is something that no one wants to give. Control is power, and
But it
no one wants.
could become obsolete. I mean, not that, and who was that? Buckminster Fuller Buckminster, what's his name? That he said, don't fight the established or something like that. Don't fight the legacy system, the existing system, but build a new one, create a new one to make the old one obsolete. Is that where you would be going?
Yeah, well, that exactly. But it's difficult. I mean, it's the only way, because the establishment, the old establishment, won't change anything. Before, we've been talking to the defense prime contractors. They won't be participating in the revolution of new systems. We see SpaceX in space, or Kratos in defense, and the cryptocurrency in the finance system, and all those innovations will happen, as you say, in parallel with the established system. There is no way for them to participate unless they are forced to do it. And governments are not going to force it. The only way to force them is if the customer is really going in that direction, because it's better. So what would help? Well, for the cryptocurrency and distributed economy, it would help if it could offer interesting, real, tangible benefits to the end user. Means, well, less expensive mortgages, or more money security, that kind of things.
No inflation for the start.
No inflation, yeah, but that is a macroeconomy.
That's what I'm saying. Bitcoin is inflationary. Bitcoin and technology, they just go hand in hand, because Bitcoin, has no. There will come a time, because it has, there's only 21 million. And then there will come a time there is no zero inflation. It's actually, it will benefit everybody, because for the first time in history, people will be able to save money, to save value, and produce and invest,
But that goes against the
against Keynesian
capitalist system.
Against the Keynesian
it goes against global economy. I mean, right now, economy is based on growth.
Right.
Basically, growth by growing technology, or growing population, or growing money.
Debt.
Money growth.
And growing
debt.
Yeah.
So usually population has been the biggest driver of growth. But that is how our economy works, how our world works right now. A company that doesn't grow is actually losing money. So growth is the real benefit in our market economy. So going against that, what we call a sustainable economy, is uncharted territory. Because and it's very difficult to coexist with the market economy. So that's why I see it would be better, but a lot of things that are better remain in the world of dreams, that will never be a reality. That's why I'm skeptic about the possibility. I mean, I'm not a skeptic about the technology and about that. I'm skeptic about that it could be eventually change how the world works. I mean, at least in an ordered manner, in a with a smooth transition. If that happens, it will be based on a revolution on something, because it's a huge change. I don't know, maybe those countries that are trying to bet on that kind of economy, like Argentina, could discover a better way of doing things. But since the rest of the world, the World Bank and all that, works in a different way, even if a whole country changed their way of doing economy, it's very difficult for even a whole country.
Yeah. I mean, would you say, I mean, if and I see that totally realistically, within, let's just say, in the next 10 to 20 years, if there's a critical mass of humanity, and it doesn't have to be really a lot, I mean, it could be like 3, 5, 10% of Earth's population, you know, adopting Bitcoin, not only as a settlement layer, but as a, you know, with the Lightning Network as a currency, you know, on a second. Would you say that would totally like shift or change your perspectives, your like what is your vision? Like, because either they're going to roll out, I mean, they will roll out the central bank digital currencies, which is totally dystopian and controlled, and it's about absolute control. I mean, in their own words, you know, Augustin Karsten, you know, the guy from Bank for International Settlements, or we're going like either, I don't know, slavery, dystopian slavery, or freedom. So where do you see ourselves? Where do you see humanity? I mean, this is something fundamentally I think we need to talk about.
It would require something like the French Revolution, you know. A real revolution. Why? Because even if people change their way of moving money, paying things and all that, the laws, the government, the banks will still be there. And if there will be always lenders and borrowers in the economy, even if there is if we use cryptocurrency backed by an algorithm instead of gold, you know. But even in that case, I mean, that would be the only case, I think, if everyone in a country just don't use the normal way of currency and they switch to a different currency.
Yeah.
But for doing that, it requires a lot. I mean, it's very difficult.
Would you say so? What if the conditions are right? You know, I mean, it's unbelievable what's going on right now, macroeconomically, geopolitically, inflation, maybe even hyperinflation. We don't know. You know, it could go into any kind of direction. But the pressure, the pain point is so much. The tipping point is already so close to implosion that people are feeling the pain economically, existentially. You know, they see. I mean, I don't think it would take too long, maybe 10 years, maybe 15, 20 years, like, you know, if we're not that optimistic, but that's what I want to know about, you know, what do you think?
But, you know, people, I mean, I see that even countries that are going through went through very bad times, they're improving. I mean, globally, poverty is being reduced, and even countries, even the China, that is a communist country, they embrace the capitalism. I mean, it's actually it's wild capitalism in China.
Yeah, is it real capitalism? But it's not free market, right? We don't have free market. Yeah.
Okay. I mean, it's well, free market doesn't exist anywhere, not even here in the States. That's an illusion.
Yeah.
Free market with borders is not applicable.
Right.
That's not free market. And all the tariffs and taxes and the limits imposed by, for instance, in the European Union to certain products that are limited. There isn't that thing of the free market.
Yeah, with all the zombie companies and the debts and the bailouts, you know, this is nothing to do with Austrian economics or, you know, rational economics. I mean, you know.
Yeah, no, China it's a capitalistic economy, but controlled by the government.
Right.
But what makes it different from the US? The only difference is that here we choose every 4, 6 years, depending on the part of the government. We choose our representatives, and in China, it's only 1 million people within the party that choose their leaders. But it's more or less the same. We have a political establishment, and there are different trends that are public here in the States, and in China is internally in the Communist Party, but they also have factions inside. Yeah, I mean,
and we have the political party democracy, you know, like where where
exactly,
people can vote the same parties over and over. I mean, it's ridiculous. It's just an illusion, you know, of
it's an illusion. Exactly, democracy is an illusion,
okay.
and has a lot of defect, you know. But probably
Thanks for articulating that, Oscar. That's really important.
but probably is the less worse, you know,
Okay.
not the worst, but there are worse ways of doing
Absolutely,
things. So I think it's not good, but it's the best thing we can do. Anyway, China is doing things very, very good, and probably they are leveraging their control, their excessive control, because that's the only difference. The difference is that here people can take a president out of there in 4 years. So they are more careful. In China, that doesn't happen. So the control and the kind of that control from the government is more visible in China than in Europe or in any Western country, or in the US. But it's about the same. They have laws, they have rules. We can think that the rules are not according to us, to our point of view, but it's a rule. I mean, it's not a wild country. It's not anarchic. It's not chaos. It's order. And
but
they
more
are
restrictive. Would you say it's more? I mean, with everything, whatever, you know, I'm always critical, you know, what I hear and what I watch, but with all this, you know, social credit system and the lockdown, and I mean, it's crazy what's going
the social credit, the citizenship, for instance. You cannot live in a city if you don't have a work. I mean, things that here we can believe that is a way of doing things, but it works for them. Even Singapore has that kind of living. I mean, most of the apartments or buildings in Singapore is owned by the government, and the government makes a long list to people that wants to live there. Not everyone can go there and live in Singapore.
I see. Wow.
So in Asia, it's very common, that way of thinking. Because probably they have feudalism more closer in time than what we had here in Europe or in the US, in the Western countries, you know. So basically, the China, the best thing that they have many bad things, like human rights violations and all that really we should have done it better when we helped China to improve during the 90s and the 2000s, that we move a lot of companies there to help them. We transfer a lot of technology, nuclear technology, aviation. So we should have forced them to do things better. Right now, we cannot change that. They are too powerful to change. I mean, to be forced to change their way of doing bad things. But they also have good things. For instance, they can plan ahead, and they plan usually for 100 years.
Exactly. Yeah. It's amazing.
So they have long-term planning at a country level. So that is really something amazing. That is something that we don't do anywhere in the Western countries.
Yeah.
We plan for 4 years or as much as 10 years. And then the plans are very fuzzy, 10 years, and maybe, who knows, but we don't have a long-term plan, long-term objectives. We see the current our governments like firefighters trying to extinguish quick fires and to maintain to keep their seats, not long-term planning. And that is what I miss. And that would be compatible with democracy. I mean, we can have here in the States, we call it bipartisan because we have two main parties. So bipartisan agreements means that it's something that can be long-term because everyone agrees on that, the vast majority. So that is the way forward, and we should have that kind of planning. And I think that that kind of planning is good for democracy. And I'm not talking about planning every little thing because I'm not so, I mean, things have to be planned, but at the top level, not very low level. So having a vision for the country and a mission for the different component, for the different departments or ministries of a country is critical. It's critical. And I've seen many times, very common in Europe, not that common here in the States, creating new ministry of whatever, or change the name, or when a new president comes in, it changes the names or the distribution of how everything works. That doesn't work. You cannot be in a constant change. I mean, you have to think about that, and that has to be a bipartisan agreement, because otherwise in 4 years the next one will come and will change everything again. And those large organizations, they need 2-3 years to settle down and to be efficient. If every 4 years you are changing and it takes 3 years to be efficient, you only have 1 year of efficiency out of 4. That doesn't work.
Yeah.
So that's the problem of democracy, of our democracy.
Exactly.
That could be fixed. That's the big thing, that we can, the same way China can learn from the rest of the world for human rights and democracy and how things can be done better, we can learn from China on how we can do things better.
Yeah, I mean, we still have to, admit that there are blatant human rights violations, even in Western or developed or whatever in these, even in Europe or United States or other continents. But just, I don't know, they are able to obfuscate it or somehow, don't make it so obvious. It's a chapter for itself. What I want to ask you is, like, we talked about China. Would you say that China, these 3 countries, because I'm myself born in Iran, but I grew up in Austria and in United States. Would you say China, Russia, and Iran, would you say they are technologically in some segments, like much further advanced or have more advantages? Or can you list a few examples?
Examples. Well, two very clear. One is hypersonics, that Russia and China are ahead of the United States or Japan or UK, and the other is nuclear technology. China is now the first one in nuclear technology, along with Russia. They are more or less the same, but China is building a lot of plants. And they are reducing the cost, they are reducing the time. They are now at about $1,900 per kilowatt of cost. That here in the States is about 5 times larger.
Jesus. Okay, that's amazing.
So they've done what Western countries did in the 60s, that is making nuclear inexpensive and reliable. So and Russia is doing the same. I mean, they have the most advanced designs are there in Russia and China. Here we have a lot of designs. We have about 80 startups and large companies trying to implement the small modular reactor. But we have the nuclear, the NRC, the Nuclear Regulatory Commission, that is a political agency committee that is anti-nuclear. So you have a regulating body that is anti-nuclear. So that's why here in the States, in the last 20 years, we only built one power plant, the Vogtle, that is a disaster. Because
is one of the
without
reasons,
building-
Oscar, because it's so stigmatized, nuclear energy, nuclear technology, or is it like a combination of other factors and reasons?
Well, basically, it was the oil and gas industry fighting against it in the 70s. Yeah, they funded, for instance, here in California. California is like Germany. It's very anti-nuclear, but that anti-nuclear thing is something that comes from that, and they got the money. The Friends of the Earth here in California, they got the money from the oil and gas industry. It was very notorious in I don't remember the name, Richard, don't remember the name, but it funded Friends of the Earth. He gave an equivalent of about $1.5 million at that time to fund the organization to fight against nuclear. And that has expanded. Similar things happening in Germany with the oil and gas and coal industry trying to fight against nuclear. So that happens here. But China and Russia, that are more practical in that sense, China overall of them, they see the benefits, and that's why China or South Korea, that is a democracy, but it has a very practical approach. They're also betting on nuclear. France did it with very good results. And it has been demonstrated that nuclear is capable of reducing emissions and
definitely. Yeah.
For instance, France reduced 88% the carbon footprint in 15 years.
Yeah.
Sweden did it in 14 years. Sweden reduced 80% or so in 14 years, also in the 70s, 80s. And Sweden, and the same happened in Ontario, in Canada. They refurbished old nuclear reactors that were closed in the 90s, and they reopened it in the from 2005 to 2015. In 10 years, they refurbish and bring back online several nuclear reactors, and they reduce their carbon footprint 89% in 10 years. So yeah, nuclear can help a lot, but the fear that is not real is something that is inside everyone, and I feel it. I grew up in the 80s, 90s, and I remember thinking that, oh, nuclear is bad, it's poisonous, it's radioactive, that it's even worse than poison.
It's because so stigmatized, also because of the nuclear weapon, and it's so overloaded with negativity and stigmatization.
Exactly, it's the mantra that has been repeated so many times that you have internalized it, and I have it inside too. I have to be very, to be very conscious when I talk about nuclear, because I had to convert myself. I converted myself from anti-nuclear to pro-nuclear because I read a lot, I learned a lot, I learned all the lies that I've been told in the past by everyone.
There's so much propaganda and brainwashing and indoctrination and missing, just so much narratives. To be honest with you, this whole, I don't want to, go into that carbon thing, because, what I hear from you also is, are you an advocate of using carbon reduction really changes the, I don't know, the climate? I mean, is that really man-made?
Well, I think that we are not going to change the climate by reducing carbon. We're not going to make it.
Okay, thanks.
So it's good to moderate our carbon footprint, but I don't think that we're going to avoid any change. I don't know if the change is going to be up or is going to be down in temperatures.
Yeah,
but the Earth is constantly changing.
exactly.
So the levels of carbon is not the important thing here.
Okay.
I'm somehow more concerned about the rate of carbon emissions.
Okay.
That I mean, the Earth has had in the past a lot more and a lot less.
See, yeah.
So any change is not going to be a big change for the Earth, for the ecosystem, for anything. Actually, CO2 is the
is actually promoting its life, right? I mean, it prosper, you know, it makes things grow. I mean, CO2.
Exactly, it's food for plants, for vegetation. So actually, I'm concerned not about the levels of CO2. I'm concerned about the rate.
Okay.
Because if
on one thing we can agree, I mean, you are an advocate. You mean we can agree of you are for the reduction of environmental pollution. I mean, you know, that's something we should be working towards, like the environmental pollution, whether it be toxins or I don't know, you know, anything that is toxic, whatever, you know, like cancerogenic or, you know, whatever.
Coal is releasing a lot of PM 2.5 particulates, small particulates that get into our lungs and they remain there. They can even pass to the bloodstream. So they are very, very small. And that comes from coal burning, not from gas burning. From gas, what we have is only nitrous oxide that could, in large quantities, could create acid rain, you know, and affect to the respiratory system. And there are many concerns about that. So that's why burning things is not the most
combustion generally is not good, right? I mean, whether it be cigarette smoking or anything.
My motivation for pushing on nuclear technology and hopefully in the future for fusion generation is to advance our civilization. I mean, it's clear. The first industrial revolution came because we started to use coal in addition to biomass, wood. So that huge amount of energy for about the same or less cost, well, it made possible to have very cheap industries to develop, a lot of industry, because we had cheap and abundant energy. The second industrial revolution came with oil and gas. Without oil and gas, we couldn't be flying from one continent to the other. We couldn't have a lot of things that we have today. Plastics. I mean, all the materials that we have today comes from oil and gas. So oil and gas is was a necessary part of the second industrial revolution. And it's been really, really good. I mean, it has bad things like coal. Coal was the reason of the first industrial revolution, but also brought bad things. But you know, anything in this world, even the best thing in the world has bad things, and even the worst thing in the world has good things.
Yeah.
So
but what we need is it advanced humanity. I mean, otherwise we couldn't have this kind of growth, and you know, actually we reduce poverty, you know, in a general sense, right?
Yeah.
I mean,
globally, it's a lot better. Obviously, it has bad things, but globally, it helped.
Yeah.
Right now, we are ready, and I think that we were ready 70, well, not 70, but probably 50, 60 years ago for the third industrial revolution. And actually, we had it more or less. We had the technology, we had the computers, and everything that comes with it, with the semiconductors. artificial intelligence, software, communications, all that came from part of the second industrial revolution, but it's the seed for the third one. But we need a portion, a very important portion for the next industrial revolution, which is abundant and cheap energy.
Exactly. Yes.
Yeah. So that's why I think that the only way forward to have a huge amount of energy that could replace part of the oil and gas and bring even more for future uses, such as, I don't know, feed powerful supercomputers, quantum computers, large artificial intelligence systems, all that requires a lot of energy. So in order to feed all that and to make it a general thing, then we will need more energy. If we want to generate all the hydrogen we need for replacing aviation, that would require a lot of energy. Generate that hydrogen, manufacture the hydrogen. So we need a lot more energy, and we need it very inexpensive. Yeah. So I believe that the only way is going nuclear. Exactly. Until fusion has been developed. That is the next step.
And then the thing beyond, I think there is something beyond fusion. I think I would call it plasma or magnetic or gravitational, but anyway, it's maybe
that is
further in the future. But I think this conversation is really important, Oscar, because with all this, ESG and, vilifying of energy bullshit that's going on, it's like, it's so anti-human, anti-growth and anti-civilization.
Not really. The narrative. ESG is a good thing, and being concerned about the environment, about our health, and about the long-term existence of our civilization and our environment is good.
Yeah, but who's the narrator? I mean, the intention is not there. It's we're all worried about environmental pollution, about environment, about sustainability, whatever you want to call it. Like growth and health.
Sustainability is a very confusing word. It's like renewable. I mean, we call wind and solar renewables, or unsustainable, but they are neither renewable or sustainable.
Yeah.
They are not renewable because a solar panel, when it's done after 20 years, it costs a lot of money.
A lot of waste. Yeah. I mean, look at all this.
And generate a lot of electronic waste. Exactly.
Yeah. All these windmills.
That is polluting because it has heavy metals.
Yeah, exactly.
And those pollutants remain pollutants forever.
Forever, yeah.
Unlike nuclear waste, that
they can be recycled, right? Reactors. They found out how to recycle, right? That's what you published about also.
We knew it. I mean, nuclear waste is not a problem. It has never been a problem. It's a problem for those that don't want to see the solution, that are anti-nuclear. Because fast breeder reactor can transmute those transuranic actinides that are the source of the radioactivity of the used fuel. Because it's used fuel, it's not waste. I mean, light water reactors, that is what we've had in the last decades, they can burn about from 3 to 5% of the fuel. So what we have is partially used fuel, very partially, only 3 to 5%. So there is a lot of energy in what we call waste. So what is the actual waste? The actual waste is not using it. The actual waste would be to bury it in permanent deposits. No. The deep geological is not the solution. It would be waste. I mean, would you put gold again inside the mine? No. Well, it's like it's the same. It's useful. It has a lot of energy. Actually, if we use fast nuclear reactor, I mean, those are called generation 4 reactors.
Yeah.
If generation 4 reactors that are nothing new, I mean, we know the technology since the 50s. It's nothing new. And Russia, they have several of them. And France had the Super Phoenix that was a fast breeder reactor and was operating for many years. So it's not new. It's just a matter of deciding to go into that way. But when fast nuclear reactors were under development in many countries, including Germany, Germany has a very good one. Then the anti-nuclear movement made the nuclear to stagnate, you know, at the end of the 90s.
Yeah.
And then after 20 years, China and Russia, again, they are developing that technology. And here in the States too, basically the TerraPower Natrium is a fast reactor. It's not a breeder reactor because it's too small, it's an SMR, but a larger version of the Natrium could be very, I mean, could burn used fuel. You know, to put this into perspective and to see how powerful nuclear energy is, the Natrium reactor, or the TerraPower Natrium reactor backed by Bill Gates, or the X-Energy, the XC100, that is another SMR under development in the US. The waste generated by the energy required by a person for the whole life, for 80 years, would be 170 grams. 170 grams of waste for your whole life.
That's amazing. Wow. Okay.
That is a little bit more than 2 grams, grams per year.
It's ridiculous.
Per person.
Yeah. This is...
So compare that to the tons of ashes and CO2 released by oil and gas.
And the environmental pollution in general. Yeah.
So basically, nuclear is clearly the way forward.
Yeah.
And it's not against ASG. It's clean. It's the cleanest one.
Well, that's really clean. Yeah, it's verifiably clean.
But it's not only clean. It's safe. It's the safest energy
and
source we have.
Yeah, and cheapest, wouldn't you say?
Yeah. I used to compare nuclear. Nuclear is to energy like aviation is to transportation. You know, it's very efficient. It's very fast. I mean, it's very powerful. It takes you there very, very quick, and nuclear generates a lot of energy. And it's very, very safe. It's the safest without any, I mean, statistics are very, very conclusive. I mean, can be more conclusive. Nuclear is the safest. Nuclear is the cleanest. But in the event of an accident, yes, it's deadly. It can have deadly consequences. It's not actually that deadly.
Yeah, but even the safety measures, or the technologies, making it more safe, more more secure, hasn't it exponentially increased in the last few decades? I mean,
it isn't. Yeah, and it's because of that, because we couldn't have mass producing them because anti-nuclear people funded by oil and gas lobbies, and followed by naive green followers that they confuse. They see nuclear as it's polluting, and it's not polluting at all. Generate a lot less waste than any other source of energy. And it's like aviation. I mean, yes, in an event of an accident, it's deadly, and a lot of people can die. But for instance, in Chernobyl, only 140 people suffer from acute radiation syndrome, and 28 died.
Yeah.
So if you put all that together, a single aircraft crash kills more than this amount of people.
Yeah.
So, and people doesn't stop flying because of that.
Exactly. Yeah.
Why are we stopping creating nuclear plants? Because one in the history killed that amount of people. One, because in Fukushima, no one died. No one had acute radiation syndrome. Nothing.
Yeah.
Nothing. The people who died was because of the tsunami, not because of the accident in the nuclear plant.
Yeah. There's a
No
lot of
one.
misinformation, and I don't know. There's just too
Yeah.
much, a lot of mainstream propaganda too behind it. Say,
Yeah,
Oscar.
there is a team from the United Nations created specifically for reviewing the Fukushima afterwards, and I'm based on that report, the unclear report, and I mean it's like that, and the data I'm saying is from that because I had to look at it yesterday. And for instance, the 3 Mile Island, the famous accident here in the US, that was a very partial meltdown of the core and released small amount of radiation. The radiation that was leaked was equivalent for the radiation that you receive in an aircraft in a flight from LA to New York. Because obviously when you fly, there are more cosmic rays that increase the radiation. A lot. But it's hard. It's not. It doesn't. I mean, it's safe. So for instance, another good thing, another good data that is very eye-opening is that Fukushima, Chernobyl. Everyone thinks that is radioactive. It's a radioactive land that is dangerous to be there. No. 1 year after the accident in the 87, 1 year after that, the radiation in Chernobyl was about half of the radiation, the natural radiation that you can find in Guarapari in Brazil, for instance. That is a very touristic city near Rio de Janeiro. And right now it's about 1/10 of the radiation, natural radiation that you can receive on the beach in Guarapari in Brazil. So really, you have to put things into perspective to learn about how the society, the oil and gas lobby has been spreading lies and fear against the best energy source that we have developed so far.
Exactly. And there's also been like this blocking or preventing like the lack of funding. Like if there was a joint effort, the multinational, whatever, like if there was a sufficient, like relatively sufficient money to fund this, I mean, wouldn't be, because that was a final question I was going to ask you. Just, I'm respectful of your time. Thanks so much for this fascinating conversation. It's so important to inform people and to make people understand the bigger picture here. Like you also publish some articles about the nuclear powered icebreakers, Russia, or nuclear modular reactors. Would it be realistic when it comes to transportation, like cars or on ground, to have modular reactor powered, I just am going to call it like that,
for instance, trains could be nuclear power with a micro reactor, no problem. Boats, obviously, all the large container vessels in our oceans, they could be powered with nuclear propulsion. They do not require that much. Icebreakers are more powerful than the engines in those mega boats. Cruise around the world. Imagine you don't need to refuel in 7 years. So the operations at ports could be a lot faster. They don't need to refuel. So it's a lot better. For aviation, it's more complicated because the weight of a nuclear reactor is too much. But probably if fusion gets, compact fusion reactors, they could be a way of power future aviation and getting rid of batteries, hydrogen.
Exactly. Yeah. So there wouldn't be like a technical, would it be technically possible if there was the willingness?
No, it's technically possible. As long as fusion could be achieved.
Okay.
But for nuclear ground systems, they could be powered.
Wow.
Mm,
Wow.
yeah, trains and sea. Yeah.
Wow, this is
Yeah.
mind-boggling, mind-boggling. This is
Yeah,
actually makes a lot of hope. It creates a lot of hope and optimism. I mean, when you hear these facts and the reality behind it, yeah.
Yeah, and as soon as you remove your fear with
Mhm.
facts, I mean, not with, I really encourage everyone to read about nuclear from people who knows about nuclear, not journalists that they just spread things,
Yeah,
but get into that, because if you don't, there is a lot more misleading information out there
yeah.
than good information from the right sources.
I agree with you totally. Yeah. No, thanks for
So
saying that. Yeah. Yeah.
that's why I encourage everyone to read and to
That,
learn
yeah.
and to get different point of views.
Yeah. No,
Yeah.
definitely. There's a handful, not too many, but I mean I've read a lot and been a lot into these rabbit holes since, because it's all interconnected, especially when you go into the rabbit hole of Bitcoin. It's,
Wow. Yeah.
it's not avoidable.
Bitcoin could leverage Bitcoin requires a lot of energy. If we
Yeah.
have cheap energy, that would be also a solution.
And that's the advantage of Bitcoin. You don't need to transport the energy. You just go to the site where the energy source is, and you just mine Bitcoin,
Exactly.
Whether it be volcano, like in El Salvador, geothermal energy, or, dams or water or hydrogen or whatever that is, it's
Yeah, you can put it in Iceland. It could be cool outside and using geothermal energy, and it's clean and
that's what,
sustainable.
yeah.
Well,
Yeah, and this will trigger, I think, hyper Bitcoinization and the exponential evolution of humanity. So
yeah,
Oscar, thank you so much again, for this conversation. I think it's overdue, and I think a lot of topics I think I'm going to break down, or at least with keywords or short descriptions. Where can people find you? Or are there any final thoughts? Where can people find your resources?
You can find me in LinkedIn. Just look for Oscar Martin, and you will find me. I don't know if you can. I can share with you. Well, you can share my.
I'll put it in the show notes. Yeah.
Link, because I used to use that social network.
No, it's really fascinating, the amount, the depth of your commentary, your expertise, the publications, the articles that you comment on. I mean, otherwise we wouldn't have really such a deep insight, what's really going on, in research and development on whether it be, energy, aerospace or quantum computing, artificial intelligence, energy, and propulsion systems.
Yeah, I love anything technology in all the areas.
That's the impression I have. Yeah. Well, Oscar, thank you so much again. Any final thoughts before we wrap it up?
Well, thank you so much for being here with you. It's been very interesting conversation.
My pleasure, my honor. Thank you so much again.
And well, see you soon.
Yeah, hopefully. Yeah, maybe we can have a conversation in the near future sometime together with Jeff. That would be a really fruitful discussion, the two of you, because you would really complement one another. But let's see. Yeah, I'll get back to you. Well, thank you so much again for your time. Oscar, bye.